In this video, we will be learning about center of gravity. So, to understand what is center of gravity, let us consider a rigid object. All the particles constituting the objects are attracted by the earth due to its gravity. We know that gravity attracts all the particles. So, here if m1, m2, m3 up to mn be the masses of the particles constituting the given object. So, here we have taken n different particles and m1, m2 up to mn are the masses of those particles. Then, like parallel forces m1g, m2g, m3g and mng, they act on these particles in vertically downward directions. And that will be towards the earth. Here we can see these are the weight acting downwards. Now all these forces are added up and the resultant force is called the weight of the object. So from here we can say the weight of the object will be m1g plus m2g up to mng. So here we can take the acceleration due to gravity constant and we can sum up the masses and we can write it as capital M. So here capital M will be the m1 plus m2 m3 plus so on mn, means total mass of the given object. Now the given object, if it is pivoted at its center of gravity, it must remain in complete equilibrium. So it is possible if the algebraic sum of moments due to the weights of the particles of the object about center of gravity is 0. So we can also define the center of gravity as the point where the net torque of the force of gravity on the object is 0. So that will be our center of gravity. So here we can see the center of gravity for some regular shaped objects. Now the position of center of gravity of an object of given mass depends on its shape. Means how it depends on its shape means how the mass has been distributed, means on the distribution of mass on it. So position of center of gravity of some uniform regular shaped object is given. So here we can see a thin rod. So the center of gravity will be in the center of the rod. For uniform circular ring or disk, the center of gravity will be in the center of the ring. A plane lamina in the form of square, rectangle or parallelogram or a rhombus. So the center of gravity will be the point of intersection of the diagonals. Here we can see. For a triangular planar lamina, the center of gravity will be the centroid. Centroid means the intersection point of all the medians of the triangle. Then for uniform hexagonal lamina, again the center of gravity is the point of intersection of diagonals. For a cubical or a parallelopipe shaped block, so for that again the point of intersection of diagonals is the center of gravity. For a thin spherical shell or a solid sphere, center of that shell or the solid sphere is the center of gravity. For solid hollow cylinder, the midpoint on the axis of cylinder, here it will be the center of gravity. For uniform solid cone, it will be on the axis of cone at a distance of h by 4 from the base. H is the height of the cone. And again for the uniform hollow cone, it will be on the axis of the cone at the height h by 3 from the base. Now if we have to determine the center of gravity of an irregular lamina, how we will do? So to find the center of gravity of an irregularly shaped object, let's say we have a cardboard sheet, we suspend the given object by tying a thread at a suitable point A. So here we have tied the object, okay, tied the thread near its surface and hang the thread from a rigid support. Now when the object acquires equilibrium, means after some time the object will be stable, it will not be moving. So that is the equilibrium state of rest. Then draw a vertical line A1 from the point A using a plumb line. So this is the plumb line. Then the line passes through the center of gravity of the sheet. So that will be the center of gravity will be lying on this particular line. Then we suspend the cardboard sheet through other points B, let's say C, etc. And in the same way, by repeating the same steps, we will mark the vertical lines B, B1, C, C1 as before. Then after we have done it, the point of intersection of all these lines will give us the position of the center of gravity of the given sheet. So this is how we can find the center of gravity for an irregular lamina. So I hope this is clear to you. Thank you.